This lab is on sampling techniques. We will study a few cases and we will decide on the sampling techniques to use. Your company has been commissioned to undertake a survey of the voting intentions of 500 electors from the Auckland area. The following alternative methods are under consideration. Discuss the potential bias in each method and how it could be minimized. Select households randomly from the Auckland telephone directly and then conduct a telephone survey with the person who answers the phone. So the potential bias in this method would be not all households are listed in the phone book. Should not just select person who answers the phone or is at home. Bias towards people who are home more often. Ask for voter to whose birthday is closest to today's date and call back. Selecting the sample of 500 from the current Auckland electoral rolls and either telephone them or visit their home. So what is the potential bias here and how it could be minimized? Biased against younger and itinerant people who may not have registered yet. To minimize the bias, could select a person at random from the household, not necessarily the person on the roll. Selecting 100 sheets in Auckland using random number tables. Okay. Selecting 100 streets in Auckland using random number tables, then during daylight hours carry out a day-to-day survey until 5 people have been selected from each street. So, using random number tables, select 100 streets in Auckland. Then during daylight hours, carry out a day-to-day survey until 5 people have been selected from each street. So what's the potential bias in this method and how it could be minimized? This method is biased towards people's home most often. Non-working and elderly people. Better to select households, then call back if no one at home FaceTime. Okay. Second case, sheets of cardboard for the manufacture of folding cartons are transported on pallets. Approximately 2,000 sheets to a pallet. The laboratory wishes to select 5 sheets from a pallet for moisture test. If the top 5 sheets were selected, explain how this could give biased results. Would this be a sampling or non-sampling error? Top sheets may have different moisture content due to exposure to atmosphere, and this is a sampling error. List 3 examples of non-sampling error that could be present in this sampling scheme. Poorly calibrated measuring equipment, misreading of measurement, transposition or key punch error. Discuss how to select the 5 sheets using simple random sampling and systematic sampling. Which method would you prefer and why? So first we will look at how to select 5 sheets using simple random sampling. Generate 5 random numbers between 0001 and 2000. Count down to these sheets and extract from the stack. And describe how to select the 5 sheets using systematic sampling. Which method would you prefer and why? So, select every 400 sheet with a random start between 001 and 400. Example 267, 667, 1067, 1467, 1867. Which method would you prefer and why? Systematic is easier and takes a sheet from each part of the stack. If you used stratified sampling, how would you stratify the sheets? Position in stack. Example, top 1/3, middle 1/3, bottom 1/3. Let's look at the third case. Activity sampling is a technique to generate the percentage of the workday that a machine spends on various activities. This is done by selecting a number of random times during the day and observing what the machine is doing at each of those times. Example, normal running, setup, stopped for scheduled maintenance, breakdown. The machine is scheduled to run between 7 a.m. and 5 p.m. Explain how you would use random numbers to select 50 random times to the nearest minute between these two times. Starting with the first column of random numbers, list the first 10 times generated by the method. "7 a.m. to 5 p.m. equal 10 hours and that is 600 minutes. So generate random numbers between 001 and 600. Which represent minutes after 7 a.m. Example 461 represents 2:41 p.m. So when we divide 461 by 60 to change it to hours and minutes, that's 461 divided by 60. We want the whole number in the remainder. So So that will be 7 hours and 41 minutes. From counting from 7 a.m., that will be 2 p.m. So 2:41 p.m. And 217 minutes represent 217 divided by 60 is 3 hours 37 minutes. So counting from 7 a.m., that's 10:37 a.m. 206 represents 206 divided by 60, that's 3 hours 26 minutes. So counting from 7 a.m., that's 10:26 a.m. And 328 minutes represent 328 divided by 60, and that is 5 hours 28 minutes. And counting from 7 a.m., that's 12:28 p.m. Describe how you would use systematic sampling to select the times. List the first 5 times selected. Select every 12th minute with a random start between 1 and 12. Example, 7:07 a.m., 7:19 a.m., 7:31 a.m., 7:43 a.m., 7:55 a.m., and so on. So we are adding 12 minutes to the previous time. Sampling technique 4. This case study is on the spare parts. A spare parts warehouse contains 4,500 product lines. The warehouse team leader wishes to select a sample of 150 product lines to check the accuracy of the computer stock on hand against the physical count. He decides to check the 150 products closest to the dispatch dock. What type of sample is this? This is judgment or convenience sampling. Why could this give biased results? Fast moving items often closest to dispatch dock may be more likely to have errors. Would this be a sampling or non-sampling error? Sampling error. So this is an example of sampling error. List 3 examples of non-sampling error that could be present in this sampling exercise. Products missing from the computer listing, which are not loaded. Miscount the quantity on hand. Transpose a number incorrectly. The warehouse is arranged in 5 aisles, labeled A, B, C, D, and E, with each aisle containing approximately 900 product lines. The simple location numbering system that identifies where products are stored is A1 to A900, B1 to B900, C1 to C900, D1 to D900, E1 to E900. Advise the warehouse team leader how to select a sample of 150 product lines, that is, locations using simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So for simple random sampling, generate 4 random a 4-digit random number 001 to 4900. First digit represents IL, that is 4 represents D, and then 618. So that's 4618, 4618 equal D618, 618. 2170 represents B170. 2067 represents B67. 3285 represents C285. 3494 represents C494. Advise the warehouse team leader how to select a sample of 150 product lines, that is locations, using systematic sampling. Select every 30th location with a random start between 1 and 30. Example A012, A042. So we add 30 to every previous number. A072, A102, A132. Next, advise the warehouse team leader how to select a sample of 150 product lines, that is locations, using stratified sampling. So for stratified sampling, select 30 items from each aisle. Each aisle, we say stratum, A, B, C, D, E. So A, B, C, D, E are also stratum. So to select 30 items from each stratum or aisle, example for aisle A generates 3-digit numbers. 815, so that will be A815. 461, that will be A461. 217, that will be A217. 727 represents A727. 206 represents A206. Next, advise the warehouse team leader how to select a sample of 150 product lines, that is locations, using cluster sampling. Could set up clusters of 10 neighboring locations. A1 to 10, A11 to 20, A21 to 30. This could make 450 clusters of 10. So 900 divided by 10. Okay, so there is a total of 4,500. So 4,500 divided by 10 is 450. This would make 450 clusters of 10. Now generate 15 times 3-digit random numbers to identify the clusters. So 45 random numbers to 15 3-digit numbers. So we need to generate 15 3-digit numbers to identify the clusters and examine all locations in the selected clusters. So 217 equal 37th cluster. In aisle C. So aisle C is from 361 to 370.